Today we're going to start talking about properties of exponents. So the first thing you'll want to notice right away is I did cross this square roots out. That's a mistake. Should say properties of exponents. So there's a whole bunch of rules for exponents, how to put them together, what some new ones that maybe you haven't seen before do and what they look like. We're going to hit a whole bunch of them in here, and then we'll kind of talk about how to get through them as quickly as we can to understand how they work. So the first one is the zero exponent. So the first part here is mathematically the definition for any non-zero number a to the 0 equals 1. One of the problems that we run into with the zero exponent is people want to say that anything to the 0, thinking of it as times 0, makes the answer 0. But a to the 0, as long as it's a non-zero number, the answer is always 1. So for example, 4 to the 0 power is 1. It's not 0, it's not 4, it's 1. If that same a is 0 now, 0 to the 0 power is what we call is undefined. Okay, so it can't be, the a can't be a 0, or else it's undefined. Any other time, if some number that's not 0 is to the 0 power, the answer is 1. So now negative exponents. So for any integer n, and any non-zero, again, so the non-zero a, basically it becomes the reciprocal. So one of the mistakes that we run into on this one is people want to say that a negative exponent makes my answer negative. It doesn't do anything like that. Okay? What it's going to do is if I have a to some negative n, what it does is it takes my base. So in this case, the base right here is a over 1, and it flips it upside down. So now it becomes 1 over a, and then this negative n exponent, once it's flipped over, now becomes a positive n. And again, notice that the a has to be non-zero. And if you think about it, it kind of makes sense. If it was a 0, then I would be trying to do something to 1 divided by 0, which was undefined, so we can't do it. But the big thing here is to notice with our numbers. It's hard with the variables, but with our numbers, notice how this 4 over 1 becomes 1/4 to the second power, which 1 squared is 1, and 4 squared is my denominator. It does not make it negative. So a negative exponent does not make my answer negative. It is flipping the base over, and then the exponent becomes positive. Okay, so let's look at a couple of quick examples. So evaluate each expression. 6.7 to the 0 power sounds like I need a calculator, sounds like I need to do a lot of work, but remember, anything to the 0 power is 1. Done. Negative 2 to the negative 4th power. So again, the negative exponent does not make it to the negative answer. It's just flipping my base, and then I'm changing from there. So first, the reciprocal of negative 2 is negative 1/2. Once I've done the reciprocal, the negative 4 becomes a positive 4. Now this is also saying evaluate. So evaluate means I need an answer. If this said just leave it as exponents, I would be done. But then remember, this is negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2. So the negatives become positive, the ones stay 1, and 2 times 2 times 2 times 2 is 16. So the answer here is 1/16. Again, notice it does not make it negative 1/16. That negative 4 has nothing to do with its sign in the front. So simplify this expression. So one of the things we also have to pay attention to is, what does the exponent go to? So thinking about what does it go to? It only goes to exactly what it hits first. So let's focus on the numerator. 4x to the 0. Well, the 0 exponent is only hitting the x. It is not hitting the 4. So basically my numerator is going to stay 4 times x to the 0 is 1. And then we have this thing down here for the moment. Okay? It is not 4x to the 0 for the 4 and the x. Got to be careful that the exponent only affects what it hits first. If it hit parentheses, and the parentheses are around the 4 and the x, then the whole thing would go to 1. Now what do we do with this negative 3? Well, let's think about it. So when I looked at this one up here, remember we flipped it upside down. So it was up here in the numerator, it flipped down into the denominator, and then the negative 4 became a positive 4. So with that same idea, this is really the same thing as 1 over y to the negative third. So when I do the negative third exponent, basically what's going to happen is it's going to flip upwards. And as it flips up, it's also going to then join the numerator as y to the positive third. So again, it was in the denominator as a negative. You can flip it into the numerator, make it a positive, and then the last thing is 4 times 1 is 4, y to the third. Then we have some properties of these exponents. So the first one is the product of powers property. Basically what this one says is anytime you want to multiply exponents of the same base, they have to be same base. Okay, so if you are multiplying same base, you add their exponents. I'm going to jump down to the bottom of this page here because this acronym MAD-SPAM is one way to help this. So MA. So if multiplying, add their exponents. So looking at my first example, I have 4 to the 6th times 4 to the 3rd, same base of 4s. Just add the exponents and get 4 to the 9th. Okay, so that's the first one. Second one is quotient of properties. When I divide, again, same base, I can subtract their exponents. So divide or quotient, subtract. And then notice, here's division. I would subtract always down, top to bottom. So 4, same bases, is 6 minus 3 is 4 to the 3rd. And then the last one of these powers for the MAD-SPAM rules, when I have power of another power, I multiply. So now this time, you only are going to see one base. So the difference between this one and the first one. So I have 2 of the same bases being multiplied. This one has one base being raised to a power that's raised to a power. So this is the power of another power. That's when I would multiply to get that. And again, as far as my MAD-SPAM, the little a is kind of stuck in there to help make it a word. But the power of a power, you multiply. So let's use some of these and see how they work. So in this first example, I can see I have the power of a product. So 3 times another base of a 3. The 3's stay, that does not become a 9. And then I can just add the exponents together to get 3 to the 8th power. The next one, same base of a negative 4. When I do the subtraction, because we're dividing, I get a negative 5. Now the negative is included inside my parentheses, so the negative 5 is going to the negative and the 4. So I need to have this as a positive exponent, so I'm first going to flip it over, and the whole thing is being raised to the 5th power now to get that answer. And then the last one is a power of a power. So base, I multiply to get z to the negative 12, but I need a positive exponent. So that means I flip it to get 1 over z to the positive 12. Now on this next one, called power of a product, we have a power, in this case the 5, of a product of two different bases. So notice these are not the same bases, but they are a product. So this is not plus, like 3 plus 2, it's times. So then when this happens, and you wouldn't necessarily do it with this case, because you might say, oh, well, 3 times 2 is 6 to the 5th power. But the way the power of a product works is the outside power has to go to both bases. And notice that it is product. So 3 gets the 5 times 2 gets the 5. So to find a power of a power, you find the power of each factor and multiply. So it is a product. Now the power of quotient is similar. You find the power of the numerator and the power of the denominator and divide. So in this case, for the same idea, I have 3 over 2 to the 5th, both the numerator, the 3 now gets the 5, and the denominator 2 gets the 5. So those two are kind of important to be watching for as you go. So let's try some examples of those. So for the first one, I have the power of a product. I have two bases on the inside of my parentheses, a negative 1.5 and a y. Both of them have to get the outside exponent. So it's kind of like the distributive property. So the negative 1.5 has to get the 2, and the y has to get the 2. So it has to be negative 1.5 to the 2nd power, y to the 2nd power. On the next example, the same idea. My numerator has to get that, and the denominator has to get that. So power of a quotient. Now these next two you really have to think out. So C is actually combining power of a product with my numerator and then power of a quotient. So the power of a product, so here's my numerator. I have two bases on the inside. So 3 gets the 4 and D gets the 4. In the denominator, 2 gets the 4. So I can definitely simplify further, go down farther, but for now I'm very happy with us just being able to get the correct exponents after we've done these things. I do not then want to think that I can do my mad span rules to take care of this quotient. These are not the same bases, so I can't say, oh, well, that's now 3 halves to the 0 power. So remember, same bases, there's nothing else that can be done here. Then on the last one, again, I've got a couple of things happening. I see a negative exponent on the outside, I see power of a power on the inside, and I see power of a quotient on the inside. So I'm going to take care of the negative 5 first. So what I'm going to first do is do the reciprocal of the inside parentheses to make it to the fifth power. So remember, the negative exponent doesn't make my answer negative. It would flip over the base. So my base, which is 2x to the third, is now 3 over 2x. Now it's to the fifth power. Now I'm going to do what we talked about, powers of quotients. Here is 2 to the fifth, x to the fifth. Very often we forget that and we just write 2x to the fifth, but 2 has to get that 5 also. And this, without going further into all my answers, would be our answer with it as exponents. So now we want to look at volume of a cylinder. So hopefully we remember a little bit of volume of a cylinder. Volume of a cylinder equals pi r squared h, where r is the radius, h is the height, and pi, which we think of as 3.14, we're going to leave as the symbol pi. So what we want to do is figure out what represents the volume here. So pi r squared h. Well, we have a height right here of the h, so that's just going to stay. But my radius, which remember is halfway through the circle, is h squared. So I'm going to plug that in. So pi, r comes out, h over 2 squared, and then h. So let's think about this. Exponents, if I think about GEMDAS, would be the first thing we've got to take care of because there's really no grouping symbols. So pi will stay, the h will stay, the h over 2 squared is the power of a quotient rule, so h squared over 2 squared, which is really over 4. Now, when I multiply across, remember this is really the same thing as h over 1, so that's going to become pi, h squared times h is h to the third. Because of the power of a product rule, I add those two exponents, and even though we don't really see it, this is really to the first power, right? So times one more h to the third, and then we're going to be all over 4. So there is our information plugged in. So that would mean there is our answer to find the volume of that cylinder, with h right now being the thing that we have for the variable. All right, and then lastly, so remember scientific notation. Scientific notation is an easy way for us to write really big numbers, like for our astrology and looking at planets' distances from each other, or our microscopic things for biology, where we have things that are tiny. And if you remember the way this works, you have some number that's between 1 and 10. It can be 1, has to be less than 10. So some number that's less than 10 but greater than 1 times 10 to some power, which is an integer. Okay? So here we have certain jellyfish that are emitting particles of light in certain amount of seconds. How many does the jellyfish emit each second? So kind of looking at that, each second tells me I am looking at photons per second. That's what our final answer is going to look like. So with that in mind, I'm going to keep my information the same. 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4th. This will help me find my answer. So let's think this one out. There's actually two fractions that are kind of working here together. I have this one that I could simplify, and I have this one that I can simplify. So let's first focus on the first one. So if I look at these two numbers, that's really saying, if I reduce that, 1/5. Okay, so if I was to take 1.25 and divide it by 6.25, that reduces to 1/5. It's the same thing. When I look at the second one now, this right here is the power of a quotient. So remember, to do the power of a quotient, if I have same bases, which we do, the base stays the same, and I subtract the two exponents, which then makes this 10 to the 12th. So what I'm going to do is go back here and take out that piece, because now that I'm seeing what's happening here, we're going to have 1.5 times 10 to the 12th. Now in scientific notation, just going to kind of give you a quick review of how that looks. 1/5 is the same thing as 0.2 times 10 to the 12th. Scientific notation says this first number has to be 1 or greater and less than 10. Well, 0.2 does not fit. So what I'm going to have to do is turn this into the number 2. Okay, so if I do that, times 10 to the 12th, because it's a positive exponent, it's making every number bigger, one more decimal place. So to adjust this, if I went 1 to the right, I would only have to now go 11. So that now is going to give me my answer in in scientific notation. Now, it also wants it in standard form. Okay, so when I look at this first one, this is scientific. Remember, standard form is 2 times 10 to the 11th means times 1 10 times 2 10s, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is what the standard form would look like if we expanded it all the way up. If you have any kind of questions, we'll be trying to focus on these for a little bit. The exponents are not that hard, but they're very important that we understand how to put them together quickly. There'll be lots of equations as you get further and further into math that you really need to know how to do these. And following these properties and these rules are very, very important. If you have any kind of questions, please let me know, and we'll hopefully be able to help you out.